In recent years, we've seen a really heavy push towards computer vision. We've seen sort of a push overall in technology representing the human experience with things like neural networks. And we see this now in autonomous cars and vehicles trying to mimic sort of a human driver, but with more eyes, right? And so to hop on this trend and to learn more about computer vision myself, I took advantage of this project to implement basically a camera that's able to sense a target. And so in mode 0, you can see here, what my robot does is it aligns the servo by moving back and forth and by rotating the servo to manipulate the camera to get as close to the normal vector of the target as possible. In mode 1, if the target is low enough, after lining up with the target, what it does is it moves forward and detects the target using the 4 ultrasonics located on the robot. And now you might be wondering, how do I do this with an Arduino? And that's an excellent question because an Arduino has very limited memory, right? And so what I do is I actually interface with Python. So I do the camera data collection in Python, and I send out the data to both the Arduino and the processing windows. And I actually confirm with Arduino when to collect the data. So what happens is Python waits for Arduino to send a flag. Once Arduino sends the flag, it begins the data collection process, and then it sends a signal to Arduino saying the data is ready. And so what is Arduino doing? Well, it first reads the data, of course. It also senses the potentiometer, which switches between the modes. It senses the distance using the ultrasonics. And it controls the motors, controls the servo, and of course calls the Python data collection. The processing displays the pose, both the orientation and the position of the target, and it displays a derived distance, essentially, and the points that the camera is seeing. The camera distance is displayed in processing in the bottom left, and it creates a server for the Python script to send the data to. So you might be wondering, how do we actually line up with the target, right? And so there's 2 steps. First, I do a very coarse sweep of the angles to get a rough idea of what angle to start at. And then I apply an optimization algorithm where I apply 9 different combinations and iterate with the best one. So first, I stay still, I move forward, and I move back. So moving in a linear fashion. And for moving forward and back, I check the distance with the ultrasonic to avoid any collisions with the robot. I also check each combination for angle up, stationary, and down, and then I pick the best combo and iterate until eventually I get within the tolerance for the normal vector. So to begin my workflow, I'm just going to upload my code, making sure that the battery is turned on, as you can see, indicated by this blue light right here. And then now that the code is uploaded, I'm going to run my processing script. This begins the server, which my Python will interface with. And then you can also see right here, the distance value is -1, and it's also red, indicating that the distance is not available at the moment. I'm going to go to my Python script, and I'm going to press, actually before I do that, I need to make sure that they're not using the same port. So then I'm going to go to my Python script, and you'll see down here in the console, some things from both Python and processing printing out. You can see it checks if the Arduino is ready, and then what it's currently doing is it's searching for the marker, which you can see right here. And you can see it got an image. And so now what it's doing is it's moving around slightly in order to optimize the location, essentially. And you can see the roll right here is within the threshold. And so this is the image that it found, and this is the location it found looking at that image. So my code found the optimized location for this position. However, I implemented a second mode where if the angle is low enough, the robot will traverse forward until they reach within the threshold distance based on the ultrasonic sensor. There we go. To elaborate slightly on some of the minor details of the project, I use a motor controller connected to the 4 motors. The left motors and the right motors are respectively wired in parallel, so I only have to use one motor controller, which obviously has an H-bridge on it, to control the directionality of the motors. And then I have 4 ultrasonics, so that uses up actually 8 digital pins. And because of the lack of remaining digital pins, factoring in all the other things, I ended up having to use the digital address of the A1 pin to control the servo. But obviously it's still a digital output as long as you use the digital address. And then I use a voltage regulator to make sure that the servo is getting the correct voltage and to not fry it from the 12-volt battery, which I turn on with a switch.